Hello and welcome back to the Data Unite channel. Today we are going to understand how to implement the decision tree regression machine learning model on a real-world dataset where we are interested to predict whether if a company spends money on a different platforms for marketing purposes such as TV, radio or newspaper will impact the sales. As you can see, I have already imported the necessary frameworks that we're going to use for this exercise, and those are pandas, numpy, and from sklearn I'm importing pre-processing that is going to be used for processing the data before using it into the model, a standard scaler to standardize the data, train and test split, which is a framework that is used to split the data into training and testing datasets. Then I'm also importing the library for the decision tree regressor, and at the end I'm also importing the metrics which are gonna be used to see the performance of the model. So first we need to import our dataset, and for that I'm gonna use the pandas framework. So it's gonna be df.pd_read CSV. And let's see the head, the first 5 rows of the dataset. Okay. Now we want also to see the shape of the dataset so that we know which are the how many rows and how many columns we have. So we do div.shape. Okay, I don't need to use brackets. So we have 200 records, and the columns are TV, radio, newspaper, and the sales. Basically, in this situation, sales is the dependent feature that we want to predict. Next we want to do some pre-processing so that we can normalize or standardize our data, and also to clean up our data so that if we have some missing values or we have some duplicates to be removed or managed. So I'm gonna do some pre-processing. And first I'm gonna check if there are some null values. So I'm gonna use the isNA function, and as we can see, we don't have any null values into any of the columns. And then we will check also if we have some duplicates. And as we can see, there are no duplicates. Duplicates means that we have more records which contain the same values for all of the rows. And at the end, it's good also to know the data type of our columns, because that will be useful in the future. Because if we have some categorical features, then we have to make them into numerical, and if we have numerical, then we have to make sure that those are numerical, because maybe in some cases you might have also some columns which should be of date type format, but they are not. So you have to manage this and to transform them into a date type. Maybe this we'll see this in the future when we will do some more data pre-processing procedures, and we will cover this into a different video. Next, what I'm gonna do is prepare the data sets for testing and for training of our model. So I'm gonna split features. So it's gonna be df dot, okay, drop x is 1 and y is gonna be df dot sales. So with this I set in the data frame X, keep all the features which are independent, such as TV, radio, and newspaper, and into the data frame Y, keep the column of sales, because that's the one that we want to predict. Okay. Now it would be good also to normalize our data into the independent features. So basically it would be good to normalize the data into the X data frame. And for that, first I need to save my the names of the columns, so that I'm gonna need this variable, because the procedure will transform the data into an array. So basically a 2D array, which is normally called matrix in mathematics. So at the end I will not have the names of the columns, so that's why I'm saving the columns into a call variable. So now I'm gonna define the scalar, so it's gonna be the standard scalar. Then I'm gonna call the scalar to our data frame. So I'm gonna fit and transform our X data frame. And now this is the step where I'm gonna transform the output from this row here. This row here now X scaled is a matrix, so basically a two-dimensional array, and I want to transform it again into a data frame so that I can continue with my operations. So that's why I'm gonna call again the function of pandas, which is named data frame, and as input takes the matrix variable and the columns. Okay, now if we see the top 5 rows, we can see that we have changed our data from some sort of values to these values. This means that with the standard scalar, we calculated each value inside of the data frame to be into a specific range. So now at this situation we don't have outliers and we have our data set normalized, and in this case our model, which is the decision trees, will not perform at least at this situation will not perform badly, but still we need to have also maybe some other operations until we reach some accuracy of the model that is let's say sufficient for our needs. But for the purposes of this video I will stop here with the transformations of the data, because now we will move on the splitting of our datasets X scaled and Y into training and testing. So for that I'm gonna put here split train and test dataset. Train X test Y and Y test. input is gonna be x scaled, and y. The test size is gonna be 30% data frame, and the random state is gonna be 100. Okay. Now we can define our model, because now the data is prepared. So next step is defining the model, training it, and then testing it. So the model is gonna be a decision tree. And I'm gonna fit the model to our training data sets. Or not. No, I'm gonna fit the model to the training input dataset, so basically the X train. Okay, decision tree regressor. Maybe I have a typo. Let me copy it from above. Okay, yeah, I had the double S. Okay, no, yeah. Okay, now that I fitted our model, and our model takes as input the training independent variables and the training dependent variable. Now our model has been tested, has been trained, and now we have to go and test it. So how can we test it? Well, basically we need to make a prediction with our model on the X test data frame, and then the output of that result, which is gonna be saved into YPred, we are going to compare it with the it's a typo, it should be Y, it should be Y test. Okay, I'm gonna rerun this too. And when I compare YPred with Y test, the result should be with values that are similar between each other, because if we have big differences between the values of these two data sets or data frames, then that means that our model is not performing well. So now let's make the prediction. I'm gonna use the model.predict function on the X test data frame, and now let's see the performance of our model. We're gonna use some of the metrics that can be used for evaluating this type of models, such as mean absolute error, mean squared error, or root mean squared error. So let's first define. I'm gonna use mean squared error, because that one is giving some results which are more, let's say, understandable. So that one I'm gonna use. So mean error and it takes, as we said before, the Y test and the YPred data frames as inputs, and then I want to print the result. Okay, so we have a value of 2 point something. This value should be as close as possible to 0, and in this situation we have a value which is very big. Even if we put root mean squared error, this is also gonna be a very big value. So in this situation we can say that our model is not performing very good for this dataset, and we might have to consider a different model which will be better performing in this for this sort of dataset. Okay, so with this we have implemented the decision trees regressor model in a real-world dataset, and as you can see, it's not that difficult, it's not that complicated, but it's important to know how to prepare the dataset and also how to read and understand the performance of the model at the end. Thank you very much for following this video until the end, and I hope you liked it. See you in the next one. Bye bye.